Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Subnetting and Network ACLs. Subnetting and Network ACLs form the backbone of secure and efficient networking within a virtual private cloud on AWS. Understanding these concepts is crucial for anyone aspiring to become an AWS Certified Cloud Practitioner. Subnetting involves dividing a larger network into smaller, more manageable subnetworks, while network access control lists govern the traffic entering and leaving these subnets. Mastery of these topics not only enhances network performance but also fortifies security, ensuring robust VPC configuration. Subnetting starts with the division of an IP address space into smaller segments, known as subnets. This division is achieved by manipulating the subnet mask, which determines the portion of the IP address that represents the network versus the part that identifies individual hosts. For instance, a common IPv4 subnet mask is 255.255.255.0, which means that the first three octets are the network portion, and the last octet is for hosts within that network. By modifying the subnet mask, one can create subnets of varying sizes according to the specific requirements of the network. In AWS VPCs, subnetting allows for the segregation of resources based on functionality and security needs. For example, you might have public subnets for web servers accessible from the internet and private subnets for databases that should be shielded from direct external access. This segregation is not only logical, but also enhances security by limiting the exposure of sensitive resources. AWS VPCs support both IPv4 and IPv6, offering flexibility in network design and addressing. The creation of subnets in AWS VPC involves specifying a CIDR block, which is a compact representation of the subnet mask. For example, a CIDR block of 192.168.1.0/24 defines a subnet that includes IP addresses from 192.168.1.0 to 192.168.1.25e5. The /24 indicates that the first 24 bits are the network portion, leaving the remaining 8 bits for host addresses. Subnetting can be further refined by using smaller CIDR blocks, such as 192.168.1.26, which divides the 256 addresses into 4 smaller subnets, each with 64 addresses. Once subnets are defined, network ACLs come into play to manage traffic flow. Network ACLs are stateless, meaning they evaluate each request individually without retaining memory of previous requests. They function as a firewall for controlling incoming and outgoing traffic at the subnet level. Each ACL has a numbered list of rules that are evaluated in order, starting with the lowest numbered rule. These rules specify whether traffic is allowed or denied based on criteria such as IP address, protocol, port number, and traffic direction. For example, you might configure an ACL to allow inbound HTTP traffic from any IP address while denying all other inbound traffic. Outbound rules could be set to allow traffic to specific IP addresses or ranges, ensuring that sensitive data is only transmitted to trusted destinations. The default ACL in AWS VPCs allows all inbound and outbound traffic, but it is advisable to customize these rules to tighten security according to the principle of least privilege. Statistics underscore the importance of meticulously configured network ACLs. According to a study by IBM, 95% of data breaches in 2016 resulted from human error, including misconfigured network settings. Properly configured network ACLs can mitigate such risks by ensuring that only authorized traffic is permitted, thereby reducing the attack surface. To illustrate the practical application of subnetting and network ACLs, consider a scenario where an organization hosts a multi-tier web application on AWS. The application consists of a front-end web server, a middle-tier application server, and a back-end database. By using subnetting, the organization can create separate subnets for each tier: a public subnet for the web server, a private subnet for the application server, and another private subnet for the database. Network ACLs can then be deployed to control access between these subnets and the Internet. For example, the ACL for the public subnet might allow inbound traffic on port 80 and port 443 while denying all other inbound traffic. The private subnets would have ACLs that deny all inbound traffic from the Internet but allow traffic from the public subnet on specific ports required for application communication. This layered approach enhances security by ensuring that even if the web server is compromised, the attacker cannot directly access the application server or database. Instead, they would need to navigate through additional layers of security controls, each governed by its own set of ACL rules. The benefits of subnetting and network ACLs extend beyond security. They also play a pivotal role in optimizing network performance. Smaller subnets reduce broadcast domains, thereby minimizing unnecessary traffic and improving network efficiency. This is particularly important in large-scale environments where broadcast traffic can lead to network congestion and degraded performance. Network ACLs contribute to performance optimization by filtering unwanted traffic at the subnet level, preventing it from reaching individual instances and consuming resources. Moreover, the use of subnetting and network ACLs aligns with best practices for network segmentation and defense in depth. Network segmentation involves dividing a network into smaller segments to isolate and protect critical assets. Defense in depth is a layered security strategy that combines multiple security measures to protect against threats. By implementing subnetting and network ACLs, organizations can achieve both network segmentation and defense in depth, thereby enhancing their overall security posture. In conclusion, subnetting and network ACLs are fundamental components of AWS VPC setup and configuration. They enable the creation of logical, secure, and efficient network architectures that meet specific organizational needs. By dividing IP address spaces into smaller subnets, organizations can segregate resources based on functionality and security requirements. Network ACLs provide granular control over traffic flow, enhancing security by filtering unauthorized traffic at the subnet level. Together, these tools form a robust foundation for secure and optimized AWS networking, aligning with best practices for network segmentation and defense in depth. As aspiring AWS Certified Cloud Practitioners, a thorough understanding of these concepts is essential for designing and managing secure, efficient, and scalable cloud environments. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.